Okay. Alright, go ahead and come in. Make sure you're at a level 0. Please go straight to your seat. Seconds right now to make sure you are in your chair. 10, 9, 8, 7, 6, 5, let's go. 3, 2, and 1. 100%. 3, 2, 1. Okay, you have 30 seconds right now to make sure pencils are sharpened and that your name is actually on your do now at this time before I give you directions on what you are doing. Everybody get their notes, their work. Yes. Need a pencil? Okay, you need to go find your pencil. You have a pencil? Oh, I got a pencil for you. No. What happened? Oh, you got the other one? Okay. 3, 2, and 1. Okay, you need to go get it. 3, 2, and 1. All right. I need everyone right now to go ahead and locate with your teammates right now. You have a set of cards that are all different standard figures. I need you to go ahead and take them apart. Go. Go make a copy of this one. It's like apparently lost me. Not enough. Yeah, make a copy. Okay, run one back in front and staple. All right, ready? Here's what I need you to do. In the front cover of your do now, you have 6 boxes. Does everybody see the 6 boxes? Okay. In each one of those boxes, I want you to work with your team. I'm going to give you about 5 minutes. How many minutes? 5. I need you to find the area of each one of these figures as a review. Please remember that in 6th grade math, we have learned how to find the area of all these figures. You need to remember what shape are they and use the formulas. Please make sure you are writing the formula down from your math chart in front of you and make sure that you are showing every single step. Do you understand, Cesar? All your work. Got it? Okay. Please make sure you're working with your teammates. You may begin. Go. You do not need the ruler right now. Okay. Each one? Each one. I like that this team went ahead and started writing their formulas down first. Okay. You're not measuring, you're using those figures. You're using the grid. So, you need to look at the grids. Each one of those units is a unit. Okay. Let's go. Make sure that you're all working together. You do not have to draw the figure, but you can if it will help you.
Area of a rectangle is
base. Square is just the same as
area of a triangle.
Okay, you might want to move them around. Each one of you can take one if it will
the
help
height
you.
is 2.
You guys make it? Okay.
Okay, so I have
Be aware of your time. How much time do you have to find the area of each one of these? No. So the base is 1, 2, 3, 4. This one together would make how many? 1, right? Because if I took it out and put it on the other side, that would be 1. Base is 4. What's the height? Okay. Yep, good job. So this is base 1 is how much? Which is base 2? Oh, 3, 2, and 1. 3, 2, 1. See, I'm trying to figure out how much you remember from doing this. You are not using the rulers because each little cube, each little centimeter square in the grid represents 1 unit. So you are using the grid in each one of these figures to actually calculate the dimensions. So this is a base, right? How long is this base? Okay, good. So how long is this base? Yes. Huh?
Wait.
This would be 6. 1, 2, 3, 4, 5, 6. This is the height, right? Okay. Alright, what is it? Where's your other shapes? You gotta do them all? You have about 2 minutes right now to find the area of each one of these figures. Base 2? There you go. Okay. So is this a what? Where's your trapezoid? So what is this that you have in front of you? Okay, so that's okay. Erase it and do it faster. Okay. I like how this table, they're really showing every single step using order of operations. The height. What's height is always at what degree angle? 90. So where do you show me what the height would be? So stop right there. Let's actually calculate it. What's your base and what's your height of your triangle?
Why did you deny a hole? You have to have space.
9.5.
Why are you doing the area?
What's your height?
Equal 8.
Or
No. 6. What's your base? What's your height? What's your base? What's your base? 4. Okay, let's go calculate it. You haven't calculated.
the area of a square is the perpendicular.
Alright. You have 10 more seconds and we are starting. Alright, 3, 2, and 1. 100%. 3, 2, and 1. Waiting on all eyes up here. We're going to go through each one. Regardless if you finish or did not finish, this is a reminder that we are going to go through it together and that you are writing down every single step on your paper for whatever you missed. Alright guys, what shape is this? This is a square. Alright, so I'm going to go to my square. Can someone tell me what is the formula you use for the area of a square, or what formula did you use? You notice the 7th grade math chart does not show square. Theo. Sure. Okay. What do I know about all the sides of a square? What do I know about all the sides of a square, Maria? The same length. All the sides are exactly the same. So my base would be what numbers? What numbers would I be multiplying for base and height? 11.
3.
Times?
3.
Great. 3 times 3 is what, class?
9.
Now, did they tell me the units?
No.
So I'm just going to write 9 what? Units? Units what?
Square.
Square. Good job. All right, hands up if you got this one correct on your paper. If not, you are writing this down because you are going to be using your do now to do another activity. All right, put this to the side. All right, what do I have in front of you guys? It's a
Triangle.
triangle or trapezoid?
Triangle.
How do you know it's a triangle? What's one of the most obvious ways you know that this is a triangle? How do you know? Nor. Well, trapezoids can also have a right angle in their height. How else do I know that this is a triangle, Jimena?
He also has triangles because it has 3 sides.
Thank you. It has how many sides? 3 sides. A trapezoid has how many sides?
4.
That's a quadrilateral. All right, ready? What's the base of your triangle? Oh, actually, let's go to triangle, right? Ready? What's your formula for area of a triangle? Should see at least 8 hands in the air at all times. Kenya.
1
Uh-huh.
times
Base times the height. What's another way that I can write the same formula? What is the same thing as multiplying by 1/2? What's another way to write it? Alexia.
base times height over 2.
Over 2? Divided by 2. Thank you. Area is equal to. All right, hands up. What's the base of my triangle? You'll have it in front of you. What is the base length of the triangle? I see 1, 2, 3, 4, 5 hands. I need more hands. All right, Cesar, what's your base? 4. 1, 2, 3, and 4. Times, what's your height? What is the height of the triangle? What is the height, Jacqueline? 1, 2, 3, 4, 5. Actually, it is 6. 4 times 6. What's the last step I need to do, class? I need to what?
Divide.
Multiply or divide?
Divide.
By
2.
2. What's 4 times 6?
24.
What's 24 divided by 2?
12.
What's my correct units? Please raise your hand. What are the correct units I'm writing for the area of this triangle? 11.
12 units squared.
Thank you. All right. Hands up if you did that one. Some of you didn't get to the triangle, but you got some of them done. All right, ready? Next one. What figure am I looking at, guys? This is a parallelogram. Great. Everyone go to parallelogram. What's the formula for a parallelogram? Okay, let's see. Who's that? Adriana. Area is equal to base times the height. All right, ready? What is the base? What is the base of the parallelogram? The base of the parallelogram. Efrata.
5.
You say 5? It's not 5. You look at it. It's 1, 2, 3. What is it, guys? 4. 4. What's the height? What is the height of the parallelogram? Let's see, 11.
2.
2. 4 times 2 is what, guys?
8.
Units?
Squared.
Thank you. All right. Please remember, actually, let me see if you remember. Height is always at what degree angle? Height is always at, how do you know that's the height? Because some of us might have interpreted 2 this way and it's not 2 this way. How do we know it's the height? Ernesto.
I always create a 90-degree angle.
It's always a 90-degree angle. It's actually a 90-degree angle with the base of the shape. All right, next one. Almost done. All right, Fofana, let's see if you got this one. What shape is this, Fofana? Trapezoid. Trapezoid has how many sides? 4. A triangle has how many?
3.
Thank you. All right, ready? What's the formula for trapezoid? This is probably one of the hardest ones. What is the formula for a trapezoid? Maria?
Plus base 2 times height divided by 2.
Great. Is this 100% correct?
No.
What's missing, Kenya?
Can you correct this?
Where?
Base ordered after base.
Why do I care that the parentheses are there? So Maria was absolutely right in the order of all her of her formula. But why do I care about the parentheses, Dennis?
You care about the parentheses because then you need to tell order operations because then it's not gonna your final answer is not gonna give you the.
So you said order of operations is what? Important. Why do I care that the parentheses are there if he's talking about order of operations? Let's add on to what he was saying, which he's totally right. John Paul?
Because it comes first.
The parentheses always come what? First. All right, ready? Let's see. What's base 1? What is base 1 for our trapezoid? Base 1. Alexia. What is it? 1, 2, 3. Actually, it's 4. Plus, what's your base 2? Base 2. Gustavo. 1, 2, 3, 4, 5, 6, 7, 8. Actually, it's 9. I need to be careful counting your grids, guys. What's your height of your trapezoid? What is the height? But thank you for trying. Muhad.
The height is 3.
And then we divide by 2. I'm going to give you time right now if you obviously did not solve this one to make sure you're doing it correctly. Make sure, thank you for those of you who are fixing your work right now. Okay. What is my first step? What is my first step in finding the area of this trapezoid? Once again, thank you for those of us who are correcting our work. What is my first step? I see 3 hands, 4 hands, 5. Nor, what is it?
4 plus 1.
Which is what, ma'am?
13.
13. Then you multiply 13 times 3 and divide by 2. What is 13 times 3? Kenya? 39. Our last step is to divide by 2. What is the area of this trapezoid? Area of this trapezoid. Okay, I'm waiting on a lot more hands than this because we are all doing this work. We are all doing this work. What is the area of this trapezoid? Why don't you have an actual pencil all day long? Not good. Does anybody have an extra pencil that Tanzila can borrow, an actual pencil? Because she's using a color pencil right now. Thank you, Gustavo. Or 11, go ahead and let us borrow. Make sure that you get your pencil back. Alright, what is the area of this trapezoid, Tanzila?
19.5 minutes.
Hands up if you agree it's 19 and 5/10. 19 and 5/10. Units what class? Square. Okay, great. Let's go ahead and circle that. Lastly, let's go to our rectangle. What was the formula is base times the what, guys? Height. What are the 2 numbers that are multiplying for the base and the height of my rectangle? Ernesto.
36 times 5.
And that gives me a total of what, Ernesto?
30
30 what?
units squared.
Thank you. Alright. Now, I'm going to give you a challenge. I want everyone to now drop their pencils. We just reviewed, and I know it's been a while. I know it's been a while since we've actually talked about area of all these figures, and I've added on circles as part of our 7th grade unit. Now, one of the things we're going to do today is we're going to talk about something called irregular figures. So I want you to think of the word regular, and then now I'm asking you, what do you think are irregular figures? Okay? Talk to your table team members right now. What do you think the word irregular means? Go. Okay. Maybe more sides or anything? What do you think irregular means?
They have a weird shape.
Alright. Okay, when you think of the word irregular figures, what do you think? Not regular? Okay, what else? Looking forward to different shapes? Okay. Alright, 3, 2, and 1. 3, 2, 1. Okay, this is where you either share what someone said at your table, and some of you, if you have not participated, you need to make sure you are participating. When you think of irregular shapes or irregular figures, what do you think Ms. Sauls is talking about? Selena? Something that is not regular? How many of you are like, yeah, irregular, not regular? Good. Okay, we're starting to think. What else do you think? What else comes up to your head? Muhad?
I think it could be shapes that don't look like ordinary shapes you see.
Okay, so when you think of ordinary shapes, what do you think of? What's an ordinary shape to you? Give me an example. A square. So you're thinking it doesn't look like anything like a square. Okay, great. Alright, so one of the things I want to mention to you is that in the real world, we do deal with a lot of irregular shapes. How many of you live in a house? How many of you, if you go to your backyard, you realize your backyard is not a perfect rectangle? My yard is not a perfect rectangle. How many of you? Okay, how many of you live maybe in an apartment complex and there's like a courtyard in the middle? Somewhere like a little grass area. Is it a perfect square sometimes?
No.
No. How many of you are like, sometimes it's like really shaped really funky? Okay? Alright, those are irregular shapes. Guess what? Someone's job at either your house or your apartment complex is to make sure that they plant grass in that area. And they need to figure out how much grass is nearby to make sure they cover every single piece. So today, the focus of our lesson is we're going to find the area of irregular shapes. Now, that's just one example. when your parents bought your house, or even when your parents, and I love that some of you are actually looking at me when I'm speaking, waiting on some people to turn their bodies around and make sure that they're paying attention. Thanks. Some of you, your parents, when they either went to the apartment complex or even to the house, they got something called a blueprint. Raise your hand if you know what I'm talking about. It's like a little picture of like where your parents live. It's supposed to like look like it's a picture that mimics what the place actually looks like on the what? Inside. So a lot of times you realize that most apartments are not actually like a perfect rectangle. Or they are, but within inside that apartment, so I'm going to have everyone turn to this board right here to kind of show you what I mean. You might have something like this. Like maybe this is your apartment complex, like, oh, not your apartment where your parents live. And then right here you have like the patio. How many of you are like, yeah, that's kind of what it looks like a little bit, right? And then within the house, you have the kitchen, and you're like, this is the living room. Here's bedroom number 1. Here's bedroom number 2. And you're like, here's the door, and there's a hallway. And you realize that these blueprints, yes, they're like little maps of where you live, but they're actually irregular what, guys? Shapes. Now today, we're going to kind of like work with that. So now I'm going to give you a task. Y'all ready? Okay, I need you to listen first so you know what you're doing. You are going to take a gray piece of construction paper that you have in front of you. Everybody see it? It's on the center of your table. You also have glue sticks. And right now, you're going to pretend that you're like a little bit like Willy Wonka. Y'all know he's a little crazy, right? Y'all know that? Okay. And you're going to pretend that you're creating a new room in Willy Wonka's house. How many of you seen Willy Wonka before? Y'all seen Willy Wonka? He has like crazy place of the factory. All right, great. So what you're going to do is, you're going to use the shapes that I gave you, all the shapes that we worked during or do now, to create a new room, an unusual room at Willy Wonka's factory. Everybody good? Now I'll give you an example. You can be as creative as you want, but I'm only going to give you about 3 minutes to create this space. Everybody good? Now I'll give you my example. This is the room that I created for Willy Wonka. Okay? I used all the shapes from my do now. Can you copy mine? Do you want to copy mine? No, you're creating your own. But you got to figure out with your team, how do you want to make this room? The more unusual, the better. Remember, Willy Wonka likes really strange things. Everybody good? All right. You have 3 minutes with your team to create this crazy room. Go. Okay, go. You have 3 minutes to glue it all together. How do you want to make it? Make sure you're going ahead and putting it on the gray sheet. Go. Here's my example, guys. I'm just putting it out here. Don't copy it. You can go ahead and start gluing it in. One more rule. All your figures have to, like, in some way, like, be connected. So you can't have, like, one shape be completely off the grid. They all have to touch your friend. All right, start gluing it. Go. Make sure you start gluing it. So you're going to need to make sure that they all touch. There. Alright, go. Make sure that you're all hands in there. Y'all two should be also telling them what to do. Don't let the boys boss you around. Making all the decisions for you. Come on. Alright, come on, gentlemen. You need to make sure that you can there you go. Okay, start gluing. Let's go. Let's start gluing it in. 1 minute and a half left. It's okay. You create a new one. Okay, let's go. seconds. Are y'all done?
That looks like it.
Let me see. Alright, what does it look like? Does not look like me. Thank you though. You think it looks like a fish? Okay. Alright. Alright. Clap once if you can hear my voice. Clap twice. Clap once. Clap twice. How many of you are like, mine looks like something? Jacqueline's, what does your unusual space look like? Your regular shape?
Like a mermaid or a fish.
Like a fish? Alright, show it to everyone. Okay, everyone, go ahead and hold up your irregular room. Go. Okay, you need to finish quickly. Okay, I'm talking over a few of you, and that's not okay. Okay, now this team in the front, I'm waiting on your attention. You have one task right now. Ready? I'm going to give you about 2 minutes. You need to find the area of your room. So think. Make the connection. We just did something in our do now. What do you think is the area of this whole room? And let me go ahead and point out that in your last box, in your front of your do now, so thank you for those of you who are looking over here, I need you to find the total area of your room. You may work with your team. Go. What do you think the total area is, guys? How do you find it? Okay, how do we find the total area of your unusual group? What do you think? Out of all your areas, your shapes? What else?
70.
What shape is that? What's the rectangle? What's that? Please remember your correct unit for your total area.
It's like an old man thing.
It looks like a what? Okay. Alright. Clap once if you can hear my voice. Clap twice. Okay. What is the area for your unusual group? Room, not group. You are in unusual groups. Alright, ready, Selena? What is your area for your room?
78 plus 5 units.
Say that correctly. 78 and 5 what?
78 and 5 times
Unit squared. Raise your hand if you got 78 and 5/10 unit squared. Do all our rooms look the same?
No.
How come we all ended up calculating the same total area? Think about that. Why did you all end up still with the same total area even though you created different rooms? Gustavo.
I think we put the same area because we still use all the same shapes.
All the same shapes. Raise your hand if you're like, yep, that's why. Does it matter how I arrange them? No. Now I want you to think. You want to add something, Jesse? Okay, great. Ready? Now I want everyone to kind of like hold it up again. Hold up your unusual groups. Groups. I don't know why I keep calling them groups. Usual rooms. They all look very, very what, guys? Different. So now I want you to think. What if you were given an unusual shaped room? How would you find the total area if it was all put together from the get-go? So let's say that I gave you the really weird room. How would you find the total area if I did this to you? I just gave you the other team's room and I said, look, find the area. Think, what would you have to do? What would you have to do if I gave you a weird shape and you needed to find the total area. Talk to your table. Go.
Find the area.
You see yours? I gave you this one. I'll go with your process of starting. Okay, you got that one. Let me see. How would you take? Okay, no. If I just randomly gave you this sheet again, how would you find the area back? Okay. Clap once if you can hear my voice. Clap twice. Alright. I went around the room right now and I gave you a new room. How would you find the area for that new room? Now we know that all of these end up having the same area, but what if I gave you a completely new problem? How would you find the area of that unusual space? What would you need to do, Jesse?
I would separate the groups into groups and then find the area of each one and then add it all up.
So you said separate it into what? Into different what? How many of you kind of said the same thing with your teams? Separate them into different what? Shapes. And then you said, what was your second step?
I will find the area
For each one. And at the end, what would you do? All right, ready? Turn to the page to your next side. Go. Okay, we're moving on to activity number 2 for today's lesson. Now, in activity number 2, I've given you a different unusual space. Everybody good? For your first task, grab a highlighter at your table. Go. By yourself, not with the help of your teammate, you have a version 1 and a version number 2. Raise your hand if you see it. Okay? Let me go ahead and switch papers so you can see it. I want you to separate, very much like Jesse said, you're going to subdivide. You're going to break apart each one of these same rooms into different shapes. But this is version 1 and this is version number what? 2. Should they look the same? No. Alright, you take about 30 seconds right now. Use a highlighter to break it down into different figures that you are actually familiar with. When you've moved on, move on to another one. There might be a figure that I've actually not taught you in part of our 7th grade. So right now, you did the same thing. So I want you to use a different highlighter. Let me get you a different highlighter. Let's see. Can I borrow yours, Gustavo? Can I switch with you? Go ahead and create. This is one, right? You have a square, a rectangle, and a what? What shape is this? So right now you have the same thing. So I want you to split it differently. Do you see it? Let me check back with you in a second, Umar. Okay, good. Oh, okay. All right. Okay. Hey. Hands up if you're like, I have 2 different versions. Okay. Please turn to someone in your table right now and share your figures. Go. Tell them what you see. Go. I You just want to break it into something that is actually easy to solve. Is that going to be easy to solve? So, I want you to switch highlighters. Okay. Perfect example right there. Alright. 3, 2, and 1. 3, 2, 1. So hopefully, you were able to see that a lot of them were like rectangles, and what other shapes did you see? Oh, semi what?
Circles.
Now, we haven't talked about semicircles at all in math class yet. But I know that you're bright enough, and I want to see if you can figure it out. Okay? I want everyone to go to their math chart right now, their 7th grade math chart. Please find the formula. Since we haven't really talked about semicircles, please find the formula and go ahead and circle it with your pencil, not your highlighter. Which is the formula you think you need in order to find the area of a semicircle? Go. Which formula do you think you actually need? this is a 7th grade formula chart because since we're talking about circles, 6th grade doesn't actually have that. No, this is yours. Here. Alright. Anybody want to volunteer? Which formula did you circle? Which formula did you circle? Cesar.
This one.
Can you read it for us, please?
A equals pi radius to the second power, square.
Second power or what, guys? Square. Talk to your team at your table right now. What do you need to do with that formula to find the area of a semicircle? Talk to them. Go. Okay, but what do you mean? Okay. Anybody have an idea? If area is equal to pi times radius squared, and I see a few hands going up. Waiting on Adriana. Thank you for correcting your work. What else would you need to do to this formula in order to find the area of a semicircle? Maria? You would need to divide it by 2. Great, you're so bright. Ready? I'm going to give you, right now, everybody see the workspace? Okay, you have exactly 5 minutes by yourself. By your what? To find the area of either, which version do you want to use? You might say, you know what, version 1 is easier. Maybe version 2 is easier. You are finding the area of this unusual space. Go. 5 minutes on your own. I'm coming around to help you in case you're stuck. Which one version do you want to use? All right, go. So you might want to split your paper into 3 pieces, right? Here's one tip. Make sure that you're breaking your workspace neatly. And make sure that you are writing down your formulas like we did during our do now. You are showing all your work. All highlighters should be closed at this time. No, because that's, what is that? What are we doing? What's this one? Are we looking for the circumference of the semicircle? We're looking for the what? Area. Okay. Okay, what is it? That's a whole circle, but once I have the area of a whole circle, if I only want half of it, what am I going to do to this formula? How do I manipulate it? What do I do? If this gives me the whole circle and I only want half of it, what do I do to this formula? Okay. But you still need to have radius to the power of 2. You don't just say 1 radius. Okay. You have 3 minutes. At this time, you've worked for 2 on your own. If you need help, you can ask a teammate. Otherwise, you're asking me as I walk around. I'm not checking answers. I'm actually just checking, or like checking with you on terms of work. So, first of all, so let's see. What do you see here? This is a what? What do you see here? What's this? So how many sheets do you have? So you need to find the area of how many sheets. So let's start with the easiest one. Which is the easiest one for you? Okay, it's right here. Go. What's the formula for area of the circle? We've got -1. for all of this figure, we gotta find the area of the whole figure. We need to find the area of the whole figure. Okay. Alright. Let me see. Well, could you be checking your work right now? Could you be checking your work right now? Okay, come on. Check your work. I'm not telling you that you're incorrect. I'm also telling you that you're wrong. No, sir. You're using a grip. Hey. Well, if it's half a circle, what do you think? Okay, you're right. Okay, what's your final answer? Okay, 11. You need to check your work. I do disagree with it.
I must touch the
Okay. 3, 2, and 1. 3, 2, 1. I need you right now to only have your pencil with you. I need you right now to stand behind your chair with your work. Go. Okay. And this is very challenging, which is why we are doing it. Okay? This is very challenging. You're going to find a new partner from a different table and compare your work and your steps and your solution at the end. Is that clear? Okay, you have 10 seconds right now to find a new partner. You are just standing up. Ready? Go. Find a new partner. Find a new partner. Let's go. Okay. 3, 2, and 1. 3, 2, 1. 11, do you have a partner? No. Okay, one is your partner. Who does not have a partner? Okay, can y'all, oh no, you're on the same. Muhad, Casey, Jimena, and Dennis are your partners. Selena, do you have a partner?
Yes.
You don't? Alright, you can be with Mauricio and Efrada. Alright, ready? You have 2 minutes right now to actually talk through the process of how you solve your problem. Go. What did you do? How did you find the area of these semicircles? Let's talk about that. Talk to each other about that. Okay. 30 more seconds. Okay. Alright. Back to your seat in 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. I don't have 100%. 3, 2, 1. Okay, I'm going to give you an example of what I actually saw because I saw a lot of people actually break it down this way. Give me a hands up if you had a version of your figure this way. It's one of the most popular ones. How many of you are like, but there's other ways to do it? There are other ways. So for the purpose of time, I'm going to go over it this way. Which shape is this, guys? This is a square. This is a rectangle. you, Mauricio, because you look like you're about to get distracted. Almost look like you're about to get distracted. You're not. Ready? What should you be doing if you made a mistake, Mauricio?
Correcting it.
Correcting it. Thank you. All right, ready? I'm going to go ahead and split my paper because I want to be a good scholar and I want to show my work correctly. I'm going to call this figure A, B, and C. Figure A is a square. That's base times height. I'm going to go over this one fast because I did not see any mistakes on this. So area is equal to 2 times 2. Area is equal to 4 units squared. Everybody good? All right, we're going to spend more time on the circle. For the rectangle, area is equal to base times height. Please make sure you're paying attention at this time and sitting all the way up. Maybe you said 1, 2, 3, 4 times 3. Area is equal to 12 units squared. Now, there are some misconceptions here about the circle, and we're going to clarify them, because this is where I saw some mistakes. The formula is, can someone remind me what's the formula that we need from the math chart? What's the formula I need for the reference chart? Gustavo.
It's area equals pi times radius squared.
And then Muhad, because it's half a circle, we talked about this, what do I need to do to this formula as well?
You have to divide it by 2.
Thank you. Now, what is pi about, class?
3.14.
About 3 and 1400, right? Times radius squared. Let's check ourselves right now. If I go back and look at the highlighted part of my semicircle, think and raise your hand. What part of the circle am I showing you? What part of the circle am I showing you? I'm going to give you a hint. You might also want to look at the strategy board right now. What part of the circle am I showing you? Tanzila. It's the what class? My formula tells me that I need my what class? My what? Oh, we're lacking energy. I need energy. I need the what? Radius. So, if diameter is given to me, what do I need to do? What is that extra step I have to take to find the radius? If I'm given diameter, there's an extra step to find radius. What do I need to do? Thank you for the participation. Tomas, what do I need to do? And you made this mistake. I saw this on your paper. Do you see it now? Yeah. What's my radius? What is my radius, Tomas? 3. All right, so give me a big hands up if you got this part correct. Ready? 3 squared. Yes? What does 3 squared actually mean? Because this is where I saw other mistakes. Does 3 squared mean 3 times 2? No. It means repeated what? Multiplication. It means multiplication of 3 times what? 3. Okay? So this becomes area is equal to pi times 9. Now, I'm not going to solve the whole thing. For those of us who did it correctly, can you double check? When you multiply pi times 9, what was your total area? I know that some of you have it correct. What is your area of a whole circle? If not, you're doing it right now, so you have that answer. What is the area of the whole circle? Thank you for those of you who are still solving it because you're trying to get it right. That back table over there. Come on. We need to see more than one hand from Kenya. What's the total area? All right, ready? Mauricio, what is it?
1.26.
That's a whole what, guys? A whole what? You know what? If you're rushing, you might just stop there. So how many of you stopped there? Oh. What do I still need to do to that area, guys? I need a what? Divide by 2. Order of operations, right? Okay, great. What is the area of the semicircle? Thank you for those of you, because I know that some of you already have it done correctly, which is great. Good job on the first time working with a semicircle. Maria.
14.13 units squared.
Now, if I want to find the area of the whole unusual space, what is my last and final step? Last and final step. 11.
The last point, you had to add all of the 3 areas.
Okay. So I say 14 and 1300 plus 12 plus 4. Can you double check your work right now and make sure you have lined up your decimals? I'm going to give you the final answer. You tell me if you got this correct. And check me, because you know I can also make mistakes. 4 plus 2 is 6 plus 4 is 10. Hands up if you got 30 and 1300 units squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's like about half of us. Not bad for our first time. Alright, ready? Ready? Okay. I'm going to challenge you now. Now it's going to get really hard. How many of you are like, that was hard? Is it hard? A little bit?
No.
A little bit? Medium? Alright, ready? Here goes hard. Turn to the next page. Go. Now I'm really going to challenge you. I gave you no grids.
Oh my god.
I did not give you any grids. And, I'm sorry, what's so funny? Y'all ready? This is a problem I used to give my 7th graders all the time. And I want to know if 2023 can actually successfully solve it with not so much of my help. Because they struggle with them. Now I want you to read the little background story to yourself. Go. I'll give you about a few more minutes to read the story to yourself. Can I get a thumbs up if you are done reading? Thumbs up. Okay, almost there. In the real world, people have pools. There are pools pretty much everywhere. Now, one thing that I had to Google, because I was like, why do people actually even buy pool covers? So, most apartment complexes, they have pools, but they don't actually cover them in the winter. But some people do. They buy like this plastic covering on top, and during the fall, especially when the leaves start falling down, they like cover them up. And I always figured, oh, they just like to put a cover over it so that it's not dirty, right? So the pool's not dirty. It makes sense to me. And I'm like, but there must be another reason why people spend a lot of money actually ordering a pool cover. And it actually turns out it's because they don't want a science experiment growing in their pool. How many of you know what algae is?
Oh.
So apparently, if you own a pool and you have a lot of like debris, which is like trash, like leaves and all these things falling into your pool, and also obviously like the change in weather, what will end up happening is you'll have a little science experiment in your pool called algae, and it will actually mess up your pool. So that is why if you've ever seen like one of those remodeling shows, anybody? No, you're too young. I'm just
Oh yeah.
I like watching remodeling shows, and sometimes they have like these really nice houses, right? And then they find out, they go to the backyard, they're like, oh, there's a pool, and they're like, they look in the backyard, they're like, ew, what's growing out of here? And it's like all green. Any of you ever seen that? You're like, what's going on? They're growing. Yeah. It actually messes up the pool. So, I'll wait till I have your eyes up here. So the story that you just read is that Miss Salas apparently has a really weirdly shaped pool, and I need to get basically a cover. But the company tells me, ma'am, we will build you, we will make you a pool cover, but you need to give us a blueprint of your pool with all your measurements and the area of your pool. Great. Here's my pool. Everybody good? I do not have a pool, Levin. I wish I did, but I don't.
She's not
Alright.
rich.
I'm not that rich. Thank you. Thanks for calling out the obvious. Thanks. Make me feel much better. Alright, ready? I'm not rich because I'm over here teaching you. Alright, ready? And it's okay, I like it. Alright, ready? This is what you need to use. What did I tell you is the one tool you get to use? What's the one tool you get to use? Some of you are literally have it in your hand. What tool did you get to use this time around? Jimena. You get to use a ruler. Okay. Alright, everyone to grab the ruler, hold it up in the air so I know you're paying attention. You're going to repeat after me. I promise. To only use. This ruler. For measuring. And and not to smack the desk or my teammates or myself. It is a math tool. Alright, you didn't repeat after me. I'm gonna make you do it all by yourself. Alright, go ahead and set it down. Go. Alright, ready? I'm gonna give you an extra ruler in case you don't have one. Alright, do me a favor. Your first task with your team, you all have to agree on it. You all have to agree on it. You need to subdivide and create the boundaries for the pool cover. So that means with a pencil and your ruler. Got it? So I'm going to give you your first minute. Go ahead and subdivide your pool. You have to agree with your team. Talk to them. Go. How do you want to divide your pool? What shapes do you see? What shapes do you see? Okay, how about 30 more seconds? Okay, so let me give you some feedback. I need you to use the ruler so your boundaries are completely straight and you actually have no movement. So, do you have an eraser? Let me borrow your eraser. Here you go. Try again. Make it something easy, right? This is the what? Triangle, big square, semicircle, right? Okay, clap once if you can hear my voice. Clap twice. Now, what made it even more challenging for 7th graders, ready? Is I told them that their goal was also, ready? Their goal was to subdivide their figure using the least amount of figures. So you could subdivide this and have like 10 different like standard shapes. So right now I want you to count how many shapes have you created. Show me with your hands. How many shapes have you created? 6. 6, 6, 6. Alright, see if you could divide it into, don't erase anything. Think, could you have done 5? I don't know, maybe you can't. Try, look at it. Could you have made just 5? Could you? Yes or no?
1, 2, 3, 4, 5,
Do you have 1, 2, oh, you made a parallelogram? And 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, 7. Just make sure 3, 2, and 1. 3, 2, 1. I want to point out Efrada's. Can I see yours? Does anybody have a parallelogram in there? No? This is the first one I saw today that I've seen. She split it into a semicircle, a triangle, parallelogram, square. It seems like a square. We'll see. Rectangles and a triangle. Okay? By the way, do we all have to have the same thing?
No.
What do you think is still going to be the same at the end? No matter how many shapes you broke it down to, even if we didn't get down to 5 figures, what should still be the same no matter what at the end? Tenzila.
The area of all the
The total what? Area.